Not that long ago, a tool like this would have cost thousands of dollars and was really only used in high-end labs or specialized industries. But now it's sitting right here in my shop and is promising to change the way I diagnose cars. For years, we've relied on tools that give us one temperature reading at a time, basically guessing and checking, hoping we land on the problem. But this isn't just a thermometer. This lets you actually see heat across an entire system in real time. And what that means is problems that used to take time, experience, and sometimes a little bit of luck can now be spotted almost instantly. So I want to put this tool to the test and see if it really can bring me out of the Stone Age. So what actually got me looking into this wasn't even me. It was my guys in the shop. A couple of them had been talking about thermal imaging and all the different ways we could use it in automotive diagnostics. And that definitely got my attention. One of my employees actually bought the Snap-on version a while ago. It was a really nice unit, but it was also a pretty big investment. For me, it just wasn't something I was ready to jump into at that price point. But now that tools like this have come down in cost and they're way more accessible, it really opened the door for me. The combination of affordability and all the potential uses made this an easy decision to pull the trigger. So now the goal is to really learn the right way how to use this tool, starting on known good vehicles, building a baseline, and figuring out exactly what normal looks like. So when a problem car comes in, I can spot that immediately. Brought a vehicle over here so I could demonstrate a couple of things for you, but I wanted to give you a brief overview before we do that of what I've been using. I've got here this infrared thermometer. This is just a typical style where you hold the button down and you point it at something, a little laser dot, and it's going to give you the temperature reading on it. So this has always been our go-to. We stick this in the duct work for air conditioning work and heating work to see what the temperature is at the duct. We put it on radiator hoses and thermostat housings to see what temperature it is. We can use it on exhaust. But what this doesn't do that the infrared thermal imaging camera does is give us the picture. So we can get a spot check on it, and we can get a temperature reading at the spot check, but we don't get any picture of it. So what I thought was kind of cool about this is to be able to kind of scan an area and look for temperature differences with this tool. So mentioned before, there's probably a ton of ways we can use this tool. And keep in mind, this is new to me, and this is something that we're experimenting with right now as we talk to you. We're still working with this tool and just trying to figure out how it can become useful. Now, as we play with this a little bit more, we're learning some more of the features on it. There's some different ways you can use this tool as a standard camera with a thermometer on it, or you can use it as a thermal imaging camera, and they've got a blend of different tools that you can do with that as well. Changing the colors of the heat map and things. So we're still experimenting with a lot of that. And we're going to try to give you the basic setup on here as we show you some of the displays on it. I wanted to talk for a minute about some of the ways I think that we might be able to use this in the future here and how we plan to maybe use this, assuming that all of our experimenting goes well. So the first and most obvious way I would probably use this is how I've been using it in the past. Simple stuff like checking to see if a radiator is actually cooling the coolant. We want to check for temperature delta or temperature difference across the radiator from the upper hose to the lower hose side. And also checking the temperature of the hoses, upper and lower hose, to see if there's some temperature differential there. Maybe checking the thermostat housing to see at what temperature that's reading, to see if the thermostat's opening correctly at the right temperature. So that's pretty basic. I think some stuff with the air conditioning, we're talking about checking duct temperatures like we do with the old style here, where we're looking for 38 to 42 degrees at the duct for air conditioning on maximum setting, and then we're looking for some heat, obviously something much hotter on the duct work before you're trying to get full heat out of it. Those things seem quite obvious, but then in the back of my mind I was trying to think of some examples of some ways we could use this abstractly. And I don't know if any of these are going to be possible or not, so we're going to play around with this for the next 6 months or so and see if we can get a baseline on some things and see if any of this stuff really fleshes out properly with this tool. But some things that I envision, maybe we'd be able to find possibly some bad wheel bearings. Maybe one wheel bearing is getting hotter than the others. If we've got a wheel bearing that's starting to fail, the metal's grinding inside of there. We could possibly look for some brake problems. So if we have a brake caliper that's sticking, maybe one of the brake pads is dragging and causing some excessive heat in that brake rotor or in that wheel, and we might be able to see a temperature difference from that one after a road test to the other side that maybe isn't binding. So another example there. I think one of my guys here was talking about maybe doing some electrical testing with it, where possibly we could look for a stuck relay. We have, in the past, we've had a lot of these Hondas with stuck AC relays. When the relay sticks on after the car shuts off, the air conditioning compressor clutch stays engaged, and then the car goes dead overnight. So this is a common failure, but it's something we might be able to see with this thermal imaging camera, where we could go over the fuse and relay box under the hood, and we would see that relay is hot because it's been running all night, or been running for much longer after the car's been shut off, or we'd see that temperature difference. The fuse box should be one temperature across it, and we get that relay, that little square box that's heating up on us. We might be able to identify that. So there's probably a lot of scenarios where we could use this. I'm envisioning maybe instead of using our exhaust back pressure tester to find a clogged catalytic converter, we might be able to just check the temperature difference between the inlet and the outlet of the catalytic converter. I also thought another example that might be kind of cool is if we could identify a cylinder misfire with the thermal imaging camera. So if we were to run across the exhaust manifold, would we be able to see one cylinder that wasn't having any output? So that temperature of that particular duct on the exhaust manifold was running cooler than the ones that were adjacent to it. So that would be interesting if we were able to do a dead misfire diagnosis with just using the thermal imaging. Maybe something a little more abstract. We might be able to determine if we're looking for a noisy pulley on the front of the engine. Maybe we think an idler pulley's bad, or maybe we've got a bearing noise in there. We don't know if it's the alternator or the water pump. I'd be curious to see, when we get to the point we've done enough testing here, if we could determine if one of those is generating enough heat to show us a difference there and pinpoint one of those things as a problem. Let's say we had an alternator bearing that was failing. We can hear the noise, we hear it grinding. Traditional method, we might be using a chassis ear to identify noise. We might be using the old stethoscope or pry bar method, listening on the alternator, listening on some of the pulleys or near the pulleys to determine where that noise is loudest. But maybe we can see that in a heat map. So these are some things, some questions that I don't have answers to yet. And of course, if any of you guys have this type of tool or you're using the garage on a regular basis, I'd love to know if you have any experience with those things. But these are the things that we aim to figure out here over the next few months as we get comfortable with this tool. And I'm really hoping that this is going to really change the way we diagnose some things. Now, I don't anticipate it's going to work great for everything. And I'm sure there's going to be some flaws in the system depending on how bad a component is. You know, if you've got an alternator where it's just about to fall apart any day now, that'll probably generate a lot more heat than one just started making noise. So I'm not saying this will work in every situation, but I anticipate that this tool may help us in those ways. All right, enough about that. Let's get into showing you a little bit of what this does and what the imaging looks like and some of the examples I've already talked about. So the first thing I thought I'd do with these two tools is just check the accuracy of my old infrared thermometer by Matco Tools to this top-down infrared imaging tool. So I'm just going to pinpoint, if this has a laser on it, you can turn on and off. And then I'm going to put the two laser dots together. And I want to see on screen here if they're both displaying the same temperature or within a reasonable amount of difference of the two. So on my left hand in the green tool, I got about 89 degrees. And then on my right hand in the thermal imaging camera, I've got about 90 degrees. So fairly close, within a couple degrees, I think is pretty good. Let's check another component here. I'm going to go both of these red dots here on this radiator hose and try to overlap them as much as possible so we're in the same spot, same distance maybe. Let me see if I get this camera a little closer. And I've got here a few more degrees difference now. I'm showing about 94 degrees in my left hand on the green tool, and I've got about 98 degrees now on the right hand. Let's check another item here. I'm going to check this coolant reservoir. And I'm going to try to get these in similar distance. So these are showing much closer here. On my left hand, I got about 83.5 degrees. Right hand, 84 degrees on the coolant reservoir. So you can see, I think these are both fairly close within a reasonable amount of accuracy. I couldn't tell you if this one was low or this one's high, or if there's something in between. We would need some more sophisticated calibration equipment in order to do that. But I think for our purposes in the garage, this is plenty close enough. Within a couple of degrees, certainly works great. And then we're going to go through some examples now. I'm going to put this one away, and we'll start using this thermal imaging camera to show some images of a few of the things we talked about. All right, so I want to show you, I'm here on this upper radiator hose. You can see we're following along. It's showing it's about 95 to 98 degrees or so along this entire hose. I want to work my way over to this lower radiator hose and give you some example of what that looks like. So we're showing maybe mid 80s here on here. I hope you guys can see the temperature there. So starting around 90, and then as I work my way down here, looks like in the middle of those or so, it's probably mid to low 80s. So what I want to do is I want to warm this car up, and I want to watch this thermal image start to change colors. And we can watch that temperature get hotter. This car is barely even warmed up, just lukewarm maybe. Let's get it warmed up and see what that looks like. So I've let this vehicle warm up a bit. I've got the air conditioning running on full blast. I want to see what the condenser looks like. I want to see what the hoses look like. So I'm quickly running this camera now over this air conditioning condenser. And this thing is showing us a difference in temperature. When I pull up here in the inlet side of this condenser, I'm running almost 172 degrees. And then if I look down across, I can see the temperature is obviously dropping as the refrigerant cools. Okay, so down about 130 degrees on the opposite side. And the way this condenser works, it should drop down to the bottom portion and work its way back across. And I believe we're seeing that here in the imaging, where you can see this darker color at the bottom of the air conditioning condenser, right? So that kind of is giving us a picture of what the heat map looks like across this entire air conditioning condenser. Oh, you can see that pretty well. So our outlet temperature is close to 115 degrees over here. And I'm going to show you the fitting. Here's the inlet fitting that we're looking at with this tool. Right here is the inlet fitting. If I can get a good bead on it, maybe we can get the temperature on there. So you can see it's about 172 degrees or so it's spiked up to. And then if I go down here, this is going to be a little trickier to get, but you can see the outlet temperature is maybe closer to 115 degrees, 120 degrees, okay? So we've got a pretty good delta difference across this condenser, with the refrigerant coming in hot on the top, working its way across, and then back to the outlet over here. And you can see that real clear delineation between the hotter side and the cooler side. I hate to say hot and cold, but I think it shows up pretty well on the imaging. So I'm thinking maybe we could find a way to use this where if we had a blockage in a condenser, maybe a compressor failed and there was something lodged in there, maybe we'd see some of these cores possibly a little bit differently in this thermal imaging than we would right now. Again, this is all going to be subject to some trial and error and see how this tool works over a longer period of time. Well guys, it's been said, one of the best ways to learn something is to teach it. So here we are learning as we're demonstrating some of these products. And something's come to my attention here as we're trying to sort out some of these heat map images. And it turns out I don't think this tool is going to work exactly like I had pictured in my head. And what we're learning here is that each image is a standalone image. In other words, when we're looking at these color gradients across the spectrum here, they're not going to be the same for every temperature in every image, only in the particular image we're looking at the moment. So what that means is I can't look at this radiator hose here that's showing up as mostly black, but is coming in at a temperature of roughly 180 degrees, and then assume that every other part on the car that's 180 degrees is also going to show up in black. Because what we're learning here is that everything in here is basically referencing every temperature this tool is picking up on the screen at once. So, basically, if I go to this lower hose, I thought maybe this one is showing here red. I would say, oh, maybe that one's going to be much hotter than this upper hose. But it's not. This upper hose is showing a dark color, which on the scale looks like it's going to be one of the coolest items in this picture. But that's only relative to what's in and around the pictures. And if you look at this picture we're looking at, I have here on the left side an alternator. I've got an exhaust manifold. And what it's doing is comparing the temperature of this hose to those much hotter parts. And therefore, that hose is looking cold to me. And then if I go over here to this lower hose is looking hot to me compared to what we just looked at on the upper hose, but the temperature is not any hotter. So this is, I guess, a learning point for us. We're going to have to be careful how we use this tool, and maybe a couple of those ideas I had at the beginning of the video probably not going to work out quite so good. But we're going to continue testing some parts here and see what we can do with this new information here I've just kind of learned as we're trying to work through this video. that we really need to be careful. We're looking at one image at a time and not trying to compare images to something else after we move the camera, because it's only going to be relative to everything that's around in the same image. Hope that makes sense. So I'm inside this car. I wanted to demonstrate to you these duct temperatures, how I would normally use my infrared thermometer and how I'm using this tool. And we're just measuring the duct temperatures. Now, obviously where you measure is going to depend a lot on what the temperature you're going to get. But overall, just kind of in the ductwork here is where I usually measure. And I'm getting a huge variance in temperatures on this machine. It's jumping as low as 29 degrees all the way up to 44 degrees. For my intents and purposes, I guess this is not accurate enough for me to use it in this scenario. This is kind of actually frustrating. So I'm going to go ahead and click on my normal infrared thermometer that I use quite often and check the duct temperature. You know, I'm kind of in here and running about 35 degrees at this duct, which is about as cold as I would expect it to get. You know, if I shoot all the way down the back of the duct, it gets down a little closer to 32 degrees. But for some reason, this tool is reading right now at 19 degrees, 17 degrees. And we know that's just not possible. This system's not going to go that far below freezing in the ductwork. You know, measure a couple of other ones and kind of give you a scenario. Same thing, I'm kind of getting about 33 degrees on the green infrared thermometer. And now I'm getting 47 degrees on this infrared imager. And it's dropping, it's wildly variant here, anywhere from 20 degrees up to 47 degrees or so. So in this example, it's kind of frustrating because although I can see a picture of temperature differential across this dashboard, it's really not useful for me in an air conditioning scenario, especially, we live here in the desert Southwest. This is a system that's highly relied upon for everybody's comfort. And if I can't get an accurate duct temperature with this, I just don't see it being useful for me in this scenario. Well, guys, I've given you a sneak peek into this infrared thermal imaging tool, and I'll give you a couple examples of where we might be able to use it. And after some analysis here, spent quite a few hours here fooling around with this tool today, probably the most I've used it since I picked it up. And my initial thoughts were this thing was going to be the greatest thing since sliced bread. But I got to tell you, after a little bit of work here, messing around with this tool, trying to figure this thing out, I think I found what it's best suited for. In all seriousness, guys, I haven't spent enough time with this tool to figure out if it's actually going to work for me the way I intended to. I think I've learned enough that it's not going to meet all my needs, all the exciting implementation ideas that I had for this tool, but I'm sure there's lots of great purposes for it. I'm just going to have to spend some time with it and continue learning. If you guys have any tips or tricks on how to best use this infrared technology, I'd love to hear about it. Thanks for following along. We'll see you in the next video.